Hey team, so this is the video for Safety 2, Homework Requirement 5. This is going to be post-occupation illumination safety using the range K method. So let's go ahead and jump right into it. So situation update. After a long day of firing at firing point 29, you receive a movement order to occupy firing point 166 for night fire. Once you arrive at the firing point, you determine a GFT setting so you can perform safety manually for illumination. You must determine post-occupation illumination safety and the maximum effective illumination area. Okay, then right below it, it gives us our GFT setting. So this is the GFT setting that was either calculated via registration or some sort of subsequent mech technique. And this is for Mike 7905, and we're gonna get back to this here in just a second, okay? Then I have my range safety card. Okay, I see I'm shooting a 777. All right, and this is only for low angle fire, and ammunition is Mike 1124. So Mike 1124, if we don't know what that is yet, because we don't see it very much, this is VL Illumination, right, in the Mike 7905 family. So it uses the same TFT as the Mike 7905, right? So Mike 1124, visual light illumination, Mike 231 Lima charges, and Mike 762. Mike 762 is a time fuse. It is a electronic time fuse specifically for base ejecting munitions. All right, so this goes on any type of munition that delivers a package, so smoke or base ejecting smoke, that is, or maybe DPICM or fast cam, something like that. Mike 762 electronic time. All right, so our firing data. Left limit is 4,300. Right limit is 5,300. Let's go ahead and find our azimuth of lay real quick. So 4,300 plus 5,300 divided by 2 gives me azimuth of lay of 4,800. I'm going to record that off to the side. Go ahead and highlight that. I like to find that right there, okay? After we have that, let's see here. So VT, not worried about it because we can't put VT on a time fuse. All right, low angle minimum range is going to be 3,000. Fuse time, min range is 3,100. Max range is 6,000. Charges 1 across the board for this firing point, which is good because that's what my GFT setting was shot with. It was shot with the charge 1, okay? So comments, looks like we have a dog leg from azimuth 4,300 to 5,000. The max range is 4,800 meters, okay? So that means we're gonna have a max range dog leg. I think that's on the left side, but we'll draw it out, okay? Survey data, here's the firing point, come over here. So we see that the firing point altitude is 376.5, which we express to 376. And that's going to be our battery altitude. All right, now let's go ahead and look at our ranges. So range 3,000, this is a minimum range, so min range, max altitude. Range 3,100, this is a minimum range, so max altitude. 4,800, this is a, where's 4,800? I am not seeing it, so it must, oh, here it is. Yep, that's the dog leg. Max range, so that is a minimum altitude, and then maximum range. This says 6,000. This says 6,600. So this actually needs to be 6,600 is what this needs to be. So we're going to square that real quick. Maximum range should be 6,600. So let's go ahead and make that square. So that's the range that we're going to be shooting at. That's our maximum range. So if that's our max range, then our min altitude is going to need to be 335, okay? Okay, so now that we finished our range safety card, let's go ahead and move over to our safety computation worksheet. So the first thing that we're going to do is we're going to copy down the GFT setting down here in the lower computational space. This safety worksheet, this is a little bit different. Mine says low angle loom safety. Yours may look a little bit different. It's all the same data, it's fine. The only thing difference though is it tells me which parts to use here, and then it has my format for max effective illumination area, right? But it's pretty much the same thing. But what I'm going to do is I'm going to copy down this GFT right here, and then we're going to draw our lazy Z out, okay? So let me move this up. Okay, so copying down my GFT setting right here. So this is going to be GFT alpha for alpha battery, charge 1, lot alpha Lima. So lot alpha refers to the projectile, so that's Mike 705. Lot Lima refers to the propellant, which is Mike 231. My should hit range is 4,870. My elevation is 3,901. Again, I'm getting all this data from right up here. I'm just copying it down. And then my time is 20.9. And down here I have total deflection correction of left 10. All right. So now that I have this copied down, so what I use is I use a skeleton just like this to make my lazy Z, right? And it gives me some other equations here. So let's see here. So let's look at this. So total deflection correction minus drift at adjusted elevation. All right, I don't know that yet. We're gonna solve that here in a second. I'm just gonna record the formula, and that's gonna give me my GFT deflection correction. Okay, and then after that, let's go ahead and get our range K over here. So range K equals my did hit range over my should hit range. So it's going to be did hit range divided by should hit range. Okay. All right, now that we have that, let's go ahead and make our lazy Z right here. So from my should hit range up to my did hit range, down to my elevation, down to my should hit time, and then over to my did hit time. All right, so now I need to extract some values from my GFT. So the GFT setting was shot with lot alpha, right? Which according to the range safety card is Mike 705. So I'm gonna extract my Mike 705 or my Alfa Romeo 2 GFT, right? Specifically for charge 1, because that's what charge the GFT setting was shot with, okay? I don't have a GFT setting applied. I don't need that because I'm using the range K method for Illum. I cannot use this GFT to calculate illumination data because this is for Mike 705 graze burst data, right? Mike 705, which is part 1 of my Alfa Romeo 2 TFT, and I need to be getting data from part 2. But I can still extract my did hit values at my adjusted elevation, or rather I can extract my values at the adjusted elevation. So what's my adjusted elevation? It's 391. So I'm gonna take the GFT, set it off on 391. Okay, and then once it's there, I'm going to extract a couple different things. So if I read up the manufacturer hairline, I see that my did hit range is 5110. If I read down, I see my should hit time fuse setting is 21.3. And then I need my drift at adjusted elevation, which is left 8. Okay, so after we have that data, we can just put that away. We're not gonna need that again. All right, let's go ahead and find some total corrections. We don't need them for this, but let's just go ahead and find them because it's a good habit. 5110 minus 4870, right? Because it's did hit minus should hit data to get my total corrections. Okay, then I have did hit of 20.9 minus should hit of 21.3. So that is negative 0.4 is my total fuse correction. Then I have my total deflection correction of left 10 minus drift at adjusted elevation of left 8. Remember, for deflections, think of lefts as positives and rights as negatives. So that's positive 8, positive 10 minus positive 8 gives me positive 2, which is left 2. Okay, that's my GFT deflection correction. All right, so after that, let's go ahead and find our range K. So range K is did hit range, which is 5110, over should hit range, which is 4870. Okay, and let's see what that equals. 5110 divided by 4870, that equals 1.04928813. And so what that's going to express to, because we express range K to 4 after the decimal point, would be 1.0493, right? Because that 813 turns that 2 into a 3. So that's my range K, 1.0493. All right, so now I have all this. I have my range K. Now that I have my range K, I can start calculating my post-occupation illumination safety, all right? But first, let's get this basic safety diagram up here. So I'm gonna put this away, get back to my range safety card here, and let's start filling out some data. So the locations, this is firing point 166. All right, the battery altitude we said was 376. We're shooting charge 1. Fuse time, there's only one fuse that can go on an illumination shell, and that's fuse time. Right, we said our azimuth of lay was 4800. All right, so after I have that, let's go ahead and start drawing our diagram. So this is gonna be my min range line. Now, common misconception is that we don't need to draw the min range line for a loom, but we do. We have to draw the min range line and the min time range line. Okay, so I've got that there. Let me think here. So this is, we have a dog leg on the left, so let me keep that short. And then it'll be long over here. Okay, and it'll be a max range, but I just gotta see where the dog leg is. So over here on the right, this is azimuth 5300. It's my right limit. My left limit is azimuth 4300. Okay, and then it says from azimuth 4300 to 5000. Okay, so that means that my dog leg is actually going to be on the right side of my azimuth of fire. Okay, so it's a good thing I waited. So it's going to be something like this. Boop. So my dog leg will look kind of like this right here. Okay. We said the dog leg azimuth was 4300 to 5000. So that's azimuth 5000. Okay. And I'm going to have a min time range. So let's go ahead and fill that in. Boom, 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 boom. Okay, so overall min range. So min diagram range we said was low angle minimum range is 3000. That has an altitude of 425. All right, and then my min time range, so fuse time is 3100. Okay, don't need an altitude for that. Then I have my dog leg max range, so max range 4800. Okay, max range 4800, min altitude is 353. Okay, and then my overall max range, which we squared to 6600. Max range 6600 has a min altitude of 335. Okay, after we have that, let's go ahead and convert to deflection. So here we go. Azimuth of fire of 4800 to get to 4300, I got to go left. How many mils left do I need to go? So that's 4800 minus 4300. I got to go left 500. Okay, to get from 4800 over here to 5300, how many mils right do I need to go? 5300 minus 4800, I got to go 500 mils to the right. And then to get from 4800 to azimuth 5000, this one's kind of tricky because we have a dog leg on the right side. Don't think too much about it, right? But basically, I'm going to go right. It'll be 200. Okay. All right, so let's now switch to deflection. So let's see here, I had to go left 500, left add, right subtract. So that's 3200 plus 500 gives me a deflection of 3700 on the left. All right, and just so I don't forget, what I'm going to do is I'm going to go ahead and add my GFT deflection correction down here. So I'm going to add my GFT deflection correction of left 2 and then make a space for drift. So I don't forget that GFT deflection correction. I don't want to forget that during my final steps of getting my final deflections, okay? So over here, so for azimuth 5000, so here we had to go right 200, so that's 3200. Left add, right subtract, so that's 3200 minus 200 gives me deflection of 3000. I didn't give myself enough room again. We're going to add GFT of left 2, and then we're eventually going to add drift. It's going to be super tiny. You may not be able to see that on the screen. Okay, and over here on the right, I had to go right 500, so that's going to be 3200 minus 500 is going to give me a deflection of 2700 on the right. Immediately add my GFT of left 2, and then add my drift, which we're going to find later. Right, it's not this drift. It's not this drift adjusted elevation. It's the drift that we're going to calculate down here. The only reason we did this down here was to get our GFT setting, get our range K, and get our GFT deflection correction. That's it. Okay. All right. So now that I have this set up, I can start coming down here and filling out the rest of this information. So this is charge 1 Lima, Mike 231. Okay. This is going to be for shell. What did we say, Mike 1124? All All right, fuse time, projectile family. So it's in the Mike 7905 family, which means we're going to use the Alfa Romeo 2, but we're going to be in part 2. Part 2 of the Alfa Romeo 2 is for Illum. Okay, so after that, do I have any sort of any range corrections? I don't have it for charge, right? Because I'm solving for charge 1 and the GFT setting was solved for charge 1. Let's see here. I don't have any square weight corrections because there is no square weight for Illumination shells. They're precision manufactured. They don't have a square weight. So I don't really ever have any sort of range correction I have to do, especially when I'm shooting Mike 705 charge 1 with a 777, because I know I don't have a muzzle velocity correction for charge 1, right? But so I can skip this, which makes this really easy. Okay. So next I'm going to move down and let's start filling in our diagram ranges. Okay, so the diagram range is down here. So diagram range 3000, 3100, 4800, and then 6600. Okay, so let's do 3000 first. Do I have a range correction? No, I do not. It's going to give me a total range of 3000. Now I multiply times my range K that we solved down here, which is 1.0493. Okay, and that's going to give me my entry range. So 3000 multiplied times 1.0493. Okay, it's going to give me 3147.9. And then I express this to the nearest 10 meters, because I always express range to the nearest 10 meters. So that comes out to 3150. And that's at charge 1. All right, so some of this information is going to stay the same, so I'm just going to pull down the 0. I'm going to pull down the range K because it applies to all my diagram ranges. I'm going to pull down the charge. Okay, so let's just go ahead and keep finding all of our entry ranges first. Let's just do that first, okay? So that's 3100 plus 0 is going to give me 3100 multiplied times range K. So 3100 times 1.0493 gives me 3252.83, which expresses to 3250 at charge 1. All right, next I have 4800 plus 0 gives me 4800 multiplied times range K, so that's 4800 times 1.0493, so that gives me 5036.64, which expresses to 5040 at charge 1. Then I have 6600 plus 0 gives me 6600 multiplied times my range K. 6600 times 1.0493, which gives me 6925.38, which is going to express to 6930, right? Because this 38 makes that 25 closer to 30 than it is to 20. So I don't artillery express here is just regular expression. So 6930. Okay, this is at charge 1. All right, so now that we have that, let's go ahead and start finding our VIs. So diagram range 3000, do I need a VI? Yes, I do. So target altitude, so 425, minus battery altitude of 376, gives me a VI of positive 49. All right, I like to find all my VIs first, and then I'll go solve for all my sight. I don't need VI or sight here at range 3100 because that's my min time range. All right, let's look at 4800. So 4800, yep, do I need it? Yes, I do. So that's 353 minus 376 gives me a VI of negative 23. All right, and then finally at 6600, I have 335 minus 376 gives me a VI of negative 41. Okay. Now that I have these, now I can start finding my sight. Now, because everything to the left of the saw black line uses diagram range, which is over here, right? And it's in the Mike 705 family, the Illum shell, Mike 1124 is in the 705 family. I can use the GST to calculate my sight, which is the preferred method, which is what I'm going to do. So I have a VI of positive 49, so set it off. Oops, my D scale is upside down, so let's fix that. What do we say, 49? Okay. 49, and I am target above gun because it's a positive VI at diagram range 3000. Oh, that's the first listed range. There on charge 1. Okay, so I've got it there. A VI of 49 Set off on range 3000. Three numbers I extract are 171. All right, 171. Place the decimal point so it makes the value as large as possible without surpassing the value of the VI. So it'd be 17.1. Express the appropriate accuracy, which would be 17. Give it the appropriate sign. Because we're low angle, the VI is positive, so that's going to be side of positive 17. All right, now let's find it for 800 with a VI of negative 23. 20212223. Okay. Target below gun because it's a negative VI at range 4800. 4800. Okay. Let's see here. So three numbers I extract are 559. So I extract 559. Place a decimal point so the value is large as possible without surpassing the value of the VI. So it'd be 5.59, which expresses to 6. And because the VI is negative, that's going to be negative 6. All right, next is this here, diagram range 6600 with a VI of negative 41. All right, VI of negative 41, so target below gun because a negative VI, 6600 as my range. So if that's 65, 68, 67, 600, okay. Let's see here, extract my numbers of 117. So 117, make the value, place the decimal point so the site is, or correction, so the decimal point, so the value is as large as possible without surpassing the value of the VI, so that'd be 11.7, expresses to 12, because site is always expressed to the nearest mill. So 12, give it the appropriate sign, which is negative. So site is negative 12 for diagram range 6600. All right, so now that we have that, we can move to the right of the solid black line. So to the right of the solid black line, I'll move this over here because we're probably going to have to interpolate. To the right of the solid black line, we're going to use entry range, right? And for the Illum, we use part 2, table chuck. Table chuck is for graze burst safety data, right? Table alpha is for firing data. We want safety data, okay? So we get our Alfa Romeo 2. I return to part 2. So part 2 begins here on page 493, but I want part 2 charge 1. Okay, so part 2, charge 1, table chuck, begins here on page 539. Okay, and I need to find elevation at my entry range. So let me grab a sticky note real quick. Grab a sticky note so I cover up all of my, anything other than my entry ranges. Here, I'll just do this. So I don't want to accidentally extract diagram range. Right, so I need to find elevation at entry range 3150. Just put this right here. Elevation at range 3150. Okay, so let's find 3150. All right, is 3150 listed value? No, it's not. So I need to interpolate. So 3150 does fall between 3100 on top and 3200 on the bottom. All right, set up my brackets. That's 50, that's 100. It's 50 over 100 equals x over. Okay, let's see. I'm trying to find elevation at 3150. I do have it for 3100, which is 200.1. And for 3200, it's 207.5. Okay, set up my brackets. That's always going to be x on the right. 207.5 minus 200.1 is going to give me 7.4. All right, cross multiply 7.4 times 50 divided by 100 gives me x equals 3.7. Express the x, the value of the column on the right. It's already expressed. So that's 200.1 plus 3.7. Add that back in. So that's 203.8. So I need to check, does that fall between these two values? Yes, it does. So 203.8 is my elevation. As I extract, I express, and I'm going to place that here. That expresses to elevation 204. All right, quadrant is a summation of elevation and site. So that's 204 plus 17 gives me a quadrant of 221. That's a safety T value. So I'm going to go ahead and circle that. All right, do I need a min time fuse setting on my min range line? Just because it's a loom doesn't change anything, right? I do not need a min time fuse setting for this range, but I do need a drift. All right, and I get that from the same table. So let me go ahead and organize my work here. All right, so let's find drift at range 3150. Okay, so I'm here in table Chuck. So let's see here. Oh, okay, well, I look here, I don't even have to interpolate because I know that 3150 falls between 3100 and 3200. So the drift value is going to be between 3.9 and 4.0, but I know what it's going to express to. It's going to express to left 4. So my drift here is going to be left 4. Sweet. All right, do I need elevation or quadrant for my min time range line? No, I do not. I also don't need drift, but I do need my min time fuse setting. So min time fuse setting at 3250. So time at 3250. All right, is it a listed value? No, it's not. But it does fall between 3200 on top, 3300 on bottom. Gives me 50, that gives me 100. So 50, 100 equals, let's set up a bracket. So what is my time fuse setting at 3200? Time fuse setting is 12.3. At 3300 is 12.7. That's X, this is gonna be 0.4. Put in the calculator just to make sure. Yep, 0.4, so 50 over 100 equals X over 0.4. 0.4 times 50 divided by 100 gives me X equals 0.2. Express the X, the value of the column on the right. I'm already good to go, so let's add that back in. So that's 12.3 plus 0.2 gives me time fuse setting of 12.5. Sanity check, does that fall between these two values? Yes, it does. 12.5 is my time fuse setting at range 3250. So 12.5. And that is a safety T value, so I'm going to go ahead and circle that. All right, next I have my max range of diagram range 4800, right, which gave me an entry range of 5040. Okay, so I need to find my elevation. I don't need a time fuse setting or drift. I just need elevation and quadrant. Okay, so elevation at 5040. Okay, looks like I'm going to have to turn the page in table Chuck here. Yep. Okay, so I'm going to be here on page 540. All right, 5040. Okay, not a listed value, but it does fall between range 5000 on top and 5100 on bottom. So what does it take to get from 5000 to 5040? That'd be 40. Here's 100, so that's 40 over 100 equals X over. Trying to find elevation at 5040. What is it for 5000? It's 360.9. For 5100. It's 371.9. That's going to be X. 371.0 minus 360.9 is 10.1 is my big bracket. Make sure I extracted the right value here. 371, yep, okay. So 10.1 multiplied times 40 divided by 100. So I'm cross multiplying here. So X equals 4.04 expressed at the X divided the column on the right. So 4.04 expresses to 4.0. So that'd be 360.9 plus 4.0 gives me 364.9. Sanity check, does that fall between these two values? Yes, it does. So my elevation is 364.9 at range 5040. Okay, as I extract, I express, so that expresses to 365. Quadrant summation of elevation in sight, so 365 minus 6 gives me 359er as my quadrant. Okay, all right, now let's find our last values here. So at diagram range 6600, my max range, so my entry range is 6930. I don't need a max time fuse setting. I will need drift and elevation though. So elevation first at 6930. Okay, 6930. Is that a listed value? No, it's not, but it does fall between 6900 on top and 7000 on bottom. So that's 30, that's 100. Okay, at 6900, elevation is 641.7. 7000 is 675.3. This is X. Let's do the big bracket here. So 675.3 minus 641.7 gives me big bracket value of 33.6. So that's 30 over 100 equals X over 33.6. Let's cross multiply. 33.6 times 30 divided by 100 gives me 10.08. Express the x, the value of the column on the right, so that expresses to 10.1. Add that back in. So 641.7 plus 10.1 gives me 651.8. So any check, does that fall between these two values? Yes, it does. 651.8 is my elevation at range 6930. As I extract it, I express, so that goes to elevation 652. All right, elevation or quadrant summation of elevation and sights, that's 652 minus 12 gives me quadrant of 640. I need to find my drift. So drift at 6930. All right, it's going to fall somewhere between 15.0 and 16.0. I think I know what it is, but let's just go ahead and do the math just to be safe. So we're going to solve for drift at, what did we say our entry range was? 6930. Okay, 6930 is not a listed value, but it does fall between 6,900 on top and 7,000 on bottom. So that's 30, that's going to be 100. Okay, drift at 6,900 is, yep, 16.0. And drift at 7,000 is 17.3. Minus 16.0 to give me my big bracket of 1.3 on the right. So 30 over 100 equals x over 1.3. Cross multiply 1.3 times 30 divided by 100 gives me 0.39, which then expresses to 0.4. Add that back in, so that's 16.4. Does that fall between these two values? Yes, it does. 16.4 is my drift at 6930. As I extract, I express. So I extract 16.4, so that comes to drift of left 16. Should have circled this quadrant earlier because it's a safety t value. Okay, so now that I have my drifts, let's go ahead and add them back in. So which side do I need to add them in on? So I'm gonna start with the left. So at deflection 3700, which side is open? Left side is open, that tells me least left. Remember, least left, most right. Least left, so that is left 4. Let's add them up. So 3700 plus 2 plus 4. Gives me a left deflection of 3706. Safety t value, circle it. All right, this one up here. So this one's a little tricky. Even though it's on the right side of the azimuth of fire, still ask yourself, which side of deflection 3000 is open? Left side or right side? Left side is open, so it's least left. So that's left 4. So that's 3000 plus left 2 plus left 4, so that comes out to 3006 is my center deflection for my dog leg. Then on the right, which side is open? Right side is open, so that's least left, most right. So most right, so that's deflection left 16. It's 2700 plus 2 plus 16 gives me deflection of 2718 on the right side. Okay, so now that I have this, let's start filling in our safety t. So I always have to record the GFT setting that I calculated this with, even though I have it recorded down here. So GFT setting alpha, charge 1, lat alpha lima, should hit range of 4870, did hit elevation of 391, did hit time of 20.9, and fuse was Mike. Technically, this fuse that they shot this was with was a Mike 767, right? So total deflection correction we said was left 10, got that from down here. GFT deflection correction was left 2. All right, so location doesn't change, firing point 166. Altitude for the battery was 376 at charge 1. Shell Mike 1124 Illum. Fuse was time, azimuth of lay was 4800. All right, what is our max quadrant for Illum? So we're gonna have since we have a max range dog leg, we're gonna have 2 max quadrants, and we're gonna have 3 deflections. All right, so let's do our deflections first. So starting on the far left, 3706 goes to the left. Working away from left to right, 3706, 3006. Now we're on the far right, 2718. Okay, so after I have that, so I have a max range dog leg, so a quadrant on the left and a quadrant on the right. The quadrant on the left is going to be smaller than the quadrant on the right because the range on the left is smaller than the range on the right. So range 4800, so what quadrant was associated with diagram range 4800? That's 359. So 359 is my max quadrant on the left, which leaves max range 6600 is 640. That's my quadrant on the right. Okay, and then the minims are easy. So what's my min quadrant for Illum? This is just the quadrant that's left over, so that's 221. Then I have my min time range, which is 12.5. Okay, so that's my safety T. But I have one more thing I have to do. For any time that I do Illum, I always have to calculate the max effective illumination area. Okay, so let's go ahead and do that right now. All right, so to calculate the max effective illumination area, I use the 7161 rule from the TFT Part 2 Table Alpha, right? Because Table Chuck is what I use for safety data, because this is for graze burst data. But I want 600 meter height of burst data for my max effective illumination area. So when you refer to page 535 of your Alpha Romeo 2, Table Alpha, you'll see that I have my range to impact, so 7 on the far right. I have my range diffuse function, which is column 6. Then I have range to target, which is column 1. So 7161 is the rule that we're going to use. So something to remember, though, is that the shaded portions, this is bad. I don't want to draw any data from the shaded portions. Shady is shady. We don't like that, okay? So I want to make sure that I'm thinking of that. So what I'm doing for my max effective illumination area, right? Let's say that this is our gun. Right, this is our target area. This is my safety box. Now, I'm going to calculate max effective illumination area off of the min time range line, and off of the overall max range. Okay, so let's just do the one on the right here. So max range 6600. Min time range of 3100. Okay, so basically what I want to do is I want to make sure that whenever I fire my projectile, whenever I fire my illumination shell, if I had a target that was here at my max range, right? If I had the illumination candle expel out of the shell here at max range, what's going to happen to that shell? It's going to keep going, and it's going to impact outside of the safety box, which is not what we want. That would be considered unsafe. So there is a spot somewhere along the trajectory where is the maximum range that a target can be to have the illumination candle expelled and the empty canister, the empty shell, still land within the safety box, right? So this is going to be our max range for our max effective illumination area, or our MIA. Okay, so I need this value here. So this is the first value I'm looking for. Then I also want to make sure, right, if I had a target that was plotted here on the min time range line, if I had a shell that I fired, it would start expelling the illumination candle before I got to the min range line. So we run the risk of having that illumination candle fall or function before it hits the min time range line. I don't want my time fuses turning on before the min time range line. So that means that there is a value right here that is going to be my min range for my MIA, meaning that there's a target here, there's a specific value here, that there's a target here where the candle can be expelled from the projectile while the time fuse does not function before the min time range line. So I need to find that. So I'm going to use the 7161 rule, okay? So let's do the 71 first. So I'm going to find a value in table alpha in column 7. We'll just call this 7161. So for 71, I want to find a value that is as large as possible without surpassing the max range of the range safety card. So without surpassing max range 6600. So let's see here. So I'm looking. I don't want to look at anything shady. Shady is bad, right? So let's flip over to the next page. Okay, so right here. So I see right here that 6596 in column 7 is as high as I can go without surpassing range 6600, because the next listed range is 6647, right? I can't use that. That busts the max range of the range safety card. So I'm going to use 6596 as my quote-unquote 7. Then I just need to look over to the left to see the corresponding value to the range to target in column 1. So that's 5200. Right? So for max range 6600, the 7-1 would be max 5200, right? Now let's do the 6-1. So now I want to find a value in column 6 that is as small as possible without falling below the min time range line of 3100. Okay, so let's see here. Without falling below 3100s. And that's it right here. So 3189 is as small as I can go in column 6 without falling below min time range line of 3100. So now that I identified that, I just look over to the left and see that the range to target is 3700. Right? So, yep. So now what I'm going to do is I can go ahead and record this down here. And I'm going to say from azimuth what to azimuth what. So we just found the MIA from this azimuth to this azimuth, right? Because we're doing the big portion first. We did 6600 and 3100. So the left azimuth is 5000. So from azimuth 5000 to azimuth 5300. Now we're talking in azimuth, not deflection, right? So the min range, so that's my 6-1 value. So the min range is 3700. And the max range we said was 5200. Okay? And so that's our MIA. So now you may be asking, well, sir, what about, so let's just go ahead and draw this on the map real quick. So we're just going to go ahead and kind of shade this in here. Because we do our max effective illumination area, we got to put it on our base safety diagram. We should also put it on our chart. We also put it on our FTO situation map, and we transmit it to the observer. It's telling the observer, like, hey, in the safety box, the only place that I can plot that you can send me calls for fire for illumination where I can achieve a 600 meter height of burst and still have everything function inside of the safety box is right here in this area. So we got to transmit to the observer. The observer needs to know that. So we said the max range here was 5200, and then the min range here we said was 3700. Okay. Now what about over here? What about this leg? Okay, so let's give it a look. So let's see here. Let's do the 7161. So 7-1. So let's find a value that is large as possible without surpassing the value of 4800. Okay, as large as possible without surpassing the value of 4800. Okay, as large as possible without surpassing the value of 4800. Okay, well, we look in column 7, and the only thing that applies to is range 4380, and that's even in the shaded portion, right? And even in the range of target is 300, which falls below the min-range line. So like, you'll be able to look at it, and it's not going to make, if it doesn't make any sense, you're like, wait, I'm not getting any values at all. That means that you can't have a MIA on this particular side. So the MIA for us for this problem is only on this side right here. So with that safety T, with that MIA, that concludes the post-occupation safety for illumination using the range K method.